Alright, for our pretension sections, we've been assuming that as soon as we release the strand, cut the strand, when it's in the bed, it transfers that stress to the concrete beam. So here's my beam. I'm just going to put a straight strand profile in here. And we've been saying that this transfers all of the stress in that strand to the beam. So I'll have my effective stress in my strand all along the length of the beam. In reality, there has to be a certain place for where this goes from 0 to full F sub SE. Likewise, if I'm at ultimate, I'm going to go from 0 to the full F sub PS. Okay, so just to transfer this over, there's got to be some length that this concrete needs to go from 0 up to the full FSE before we put on load, and then at ultimate to go from 0 to the full F sub PS, which is what we're assuming when we do our phi-m-n calculation. Right? That's the equation we use to get to the capacity piece. So if I were to plot this and have my stress along one axis, so I'll have my F sub PS and then also my F sub SE, I'm going to need a certain length to get to F sub SE, where I transfer the pre-stress over. Then I'm going to have another length of which to transfer over the full F sub PS at the nominal capacity of the member. Okay, so this is at nominal or full strength for our calculation, and this is pre-stress only situation. Alright, those two lengths, this one is called L sub t, which is the transfer length, and then that full length you need from here all the way to F sub PS is your development length. Alright, in the code, the way we handle this is through a set of equations for those two things. So this first piece, the L sub t piece, is given in the code as F sub SE for your situation, for your beam, over 3000 times D sub B, and this is, in this case, your diameter of your strand, or your bar. So if it's half-inch diameter strand, we put 0.5 inches in there. This guy here, to make the units work out, needs to be in, having issues here, needs to be in PSI. Let's somehow switch things here to PSI, okay? Then we have our full development length, and that's equal to the transfer length plus this additional distance that takes us from S sub SE up to F sub P, from F sub SE up to F sub PS. So that quantity is the difference between those two, and again times the bar diameter. Okay, so that full equation, these are the two equations, but this is the full equation for development length. And it's basically as simple as that. You'll then want to be putting these into your programs so that when you start getting a capacity, it's not going to be for a straight strand constant capacity. It's going to go from 0 up to that capacity over a certain distance. And we'll work some problems in class, but essentially this can be pretty significant. The full development length could be 5, 6, 7 feet or more, depending on your situation and how much strain you have, and the forces you have. And so it can be an issue. If your beam is long enough, it'll be able to develop that capacity along the length of the beam. So if this is the, say, ultimate, and that's the development length, I've reached my full capacity. This would be a straight strand case. If the beam is too short, I might not actually get to this full capacity over the development length. So I have to check this to make sure what my actual capacity is, not what I think it would be based on a fully developed section. Excuse me. We have one more thing to consider, and that is debonded. In the debonded situation, where we have a strand and at the end we have a section where we put the plastic cap over to debond it, okay, that strand starts developing where it actually touches the concrete, okay, and in this case we need to use 2 times the development length, also 2 times the transfer length. So for your debonded strand cases, those strands you have to multiply by 2 those development lengths, so it can be considerably long where you're doing this development. All of what I've showed you here is for pre-tensioning. For post-tensioning, we have a separate case, and I'll be talking about that in class. But essentially, we assume that with post-tensioning, you have everything anchored at the ends. You transfer that over, and so you can reach the full pre-stress in that strand right away along the length. And so we'll get into some more detail with losses about how things might change along the length, but essentially we don't have a ramping up or development length. What we do end up with is a lot of bursting stresses right here at the anchor zone, and so we have to put some special reinforcement in that local zone to do that.